Good morning, everyone. Welcome to 1C. Let's talk about adding and multiplying radicals. That is our objective for today. I can add and multiply radicals. So I want to briefly recall a time when you learned about addition and how it relates to multiplication. For example, one of the first things that you learned in your math career was how to add numbers. So if I had 7 plus 7, you either take your fingers and count, or you just kind of eventually learn that 7 plus 7 is equal to 14. But a little bit later in your math career, you learned how to represent this as multiplication. Because this is 7 plus 7, you have two 7s. So one way you wrote it was 2 times 7, which is equal to 14. And this concept is big, right? This jump is a huge jump. So for example here, if I have x plus x, that is equal to 2x. Or you could think of it as 2 times x, right? Which is then equal to 2x. This is massive. This is huge. And it's really understated, when you're going from first grade to third grade is right around that time. The fact that addition and multiplication are essentially the same thing is often lost in translation. So again, if I have AB plus AB, it's equal to 2AB, or 2 times AB. So let's then shift gears. The new thing that we've been learning in this unit are radicals. So how would this work with radicals? And the answer is exactly the same as this here. Unfortunately, we don't really have access to this left side. We're instead going to be focusing on this right side here. This is kind of the formula or the method that we're going to be using. So here I have the square root of 3 plus the square root of 3. Well, how many square root of 3's do I have? We have 2. So this is going to be 2 times the square root of 3. Just like that. Now we'll do some variables. So I have the square root of x plus the square root of x plus the square root of x. So how many square root of x do I have? I have 1, 2, 3, which means I have 3 times the square root of x. Here's where we get into a fun example that I think will throw some people for a loop here. I have 2 root x's, and then I get another 3 root x's, so plus 3 root x, and then plus root y. So one of the things you can always do is treat this like apples, right? So if I have 2 apples and I get 3 more, how many do I have? Well, that'll be 5, right? I have 5 total root x's. And then here's root y, which is not root x. It's a completely different thing. So I can't combine it with the root x mathematically. I just have to add it on at the end there. So if we want to go back to this apples example, it's like I have 2 apples and I get 3 more, and then I get an orange. Well, I have 5 apples and an orange. I have 5 x's and a y. And here's an important another rule here. You have to look at the index, the root, this little number that's kind of in the wedge of the radical in that little triangle place. We do have to care about that. So if I have 3 times the 4th root of a plus 5 times the 4th root of a, these two I can combine. I can put those together. So 3 plus 5 is 8. And I'm still going to retain that 4th root quality of a. Now I can't combine it with this 2. I can't add 2 more to this because this is the 6th root of a. So I'm just going to add that on at the end there. Because I can't combine them. I can't put them together. So the rule is when adding radicals, you add the outside. You don't add the root or the index. There's something else that should be important here. The indexes and bases must be the same.